Well, let's say, for example, we're trying to classify the number negative 13. We're trying to lump it into all of its possible categories. Using that chart there on number 7, just kind of working our way down the list there. Actually working our way across the top, it looks like. Negative 13, is that an integer? It's a nice whole number, isn't it? So yes, it is an integer. Is negative 13 a digit? Would you ever use that number to make up another number? No. Digits are only 0, 1, 2, 3, all the way up to 9. So negative 13 is not a digit. Is negative 13 even? For something to be even, it must be divisible by 2 evenly, right? Not so much, is it? It's not positive. It is negative. Is it a rational or irrational number? Okay, and of course we are assuming it's real in the first place, aren't we? But this would be a rational number because we can write it as a ratio of two integers. Those two integers, it would be negative 13 over 1, right? So this is rational. It's not irrational. It's not imaginary, it's real. And what's left here? Is it a natural or counting number? Do you guys count with negative numbers? No. And it's not going to be transcendental because we've already ruled out the irrational side. So that's some of the categories we can place negative 13 under. All right, another one we could look at here, because it brings up some kind of unique situations. 0. If we had to classify 0, going through that same list. Is 0 an integer? Is it a whole number? Yeah, it is. It's an integer. Is it a digit? Yes, we could use 0 to develop other numbers. Is it even? This is where it gets interesting. Why? Yes. You can divide it evenly by 2. It's even. Is it positive or negative? Neither one of those, is it? It's just 0. It divides the positive from the negative numbers. Is it rational? I would say it's rational. Right? A rational number is a number you can write as a ratio of two integers. If 0 is an integer, we could put 0 over 2. Right? That would work, wouldn't it? So if it's rational, it's not irrational. All right, so continuing down the list, we've got imaginary or real. This would be real. Has to be if it was rational. Natural or counting numbers. Does this qualify? This is kind of what we were just talking about, right? Normally I start my counting with 1, but in certain circles it qualifies. So natural, counting, go hand in hand here. And then it's not transcendental because it's not irrational. All right, how we classify 0.9 repeating. Is it an integer? No, because it's a decimal. It's not a digit. It's not even. It is positive, right? What else we got here? It's not negative. Is it rational? It's a repeating decimal. Yes, it's rational. Therefore, not irrational. Not imaginary, must be real. It's not a natural or counting number. It wasn't irrational, therefore it's not transcendental. So That's all the categories for 0.9 repeating. Using the given sets J and K, let's introduce one of our new symbols, a little union symbol. Let's find the union between J and K. That's what that represents there. Well, to find the union between J and K, we want to consider all the elements that are in J, all the elements that are in K, and make sure that everybody is included. That's what a union is all about. So, there's a 3 in both, there's a 12 in both. Obviously, down here, we want to include 3 and 12. Now, there's a 76 up here, there's not a 76 down here, but that doesn't matter. We still want to include it. Just like there's a 94 down here, there's a 2000 down here, not included in the first one. We still want to include it. Everybody needs to be included. So as everybody's included, we're going to form a new set that represents this union. In that set, we'll have 3 and 12, just happen to be contained in both, but we're also going to include 76, 94, and 2000 because they have to come to the party too. That's how a union works. Now, somewhat on the flip side would be an intersection. So we take this little U symbol, we flip it over, and now we're talking about the intersection between these two sets J and K. The intersection is a little more restricted. We're looking to see what overlap is occurring between the two sets. So in other words, what elements are shared between the two sets. As we've already discussed here, 3 and 12 are the ideas that are shared between the two sets. So the set 312 would represent the intersection. As long as we have these two sets up here to use as an example, let me give you one final question. Little true false. So we can throw another symbol in here. Let's talk about subsets. Is J a subset of K? So there's that sideways U. It's not?
Because it doesn't have 76.
Okay, there you go. J is a smaller set, so it could make sense that maybe it's a subset. 3 is there, 12 is there, but 76 is not represented in the remaining elements. So because 76 is not represented in the remaining elements, we cannot say that J is a subset of K. So this would be false. Now if J included just 3 and 12, would it be a subset? Yes, it would be. It would be a subset